tasks to complete for today. This is Unit 1, Lesson 7. So you're looking for tasks for U1L7. You can either go to the Canvas homepage and go to the weekly calendar and find the date. Remember to scroll down to the calendar for B section, UR section B, or look under assignments for Science2B, tasks for U1L7. First thing I wanted to do is just a homework review. You had to complete the Hewitt chapter 5.1 through 5.4 reading reflection. It was just a quick introduction to gravity. Are we feeling good about that? Anyone have any questions there? I think it was only 4 questions, but. All right. And then just make sure you've posted your solar system project links. I'm seeing 6 responses on the discussion board, which is great. So I wanted to, for the do now, to reflect on an assignment that I gave you guys last week, which was the talking about gravity. If you remember, there was a Google form where I gave you a situation. There were 2 people talking, Ben and Kelly, about their perception of gravity. And Ben was essentially saying, well, when we're here on Earth in the atmosphere, gravity, everything falls. But when you see an astronaut out in space, they're floating around, right? So gravity needs an atmosphere. Kelly was saying, no, gravity doesn't need an atmosphere. It could exist anywhere, regardless of whether there's gas on the surface of a planet or not. And I have the numbers there. So filling out the form, 7 of you selected Ben, 8 of you selected Kelly, which is a pretty even divide. So what I want to do now is throw you into breakout rooms of 2 for just 3 minutes. And I want you to just introduce yourselves if you don't know each other, and then share who you picked and share your reasoning, right? Why did you agree with Ben, or why did you agree with Kelly? See if you can remember who you chose. And we'll come back and reflect on that a bit. So, and Sean is here. Let's let Sean in 1 second. Hi, Sean. We're going into breakout rooms. Whoever you're paired with will explain what's going on.
All right.
Let's see. Okay, breakout rooms are open. Go for it. All right. So, Angel, who do you remember agreeing with, and what was your reasoning?
I agreed with Ben, but I changed it to Kelly because I thought that it meant that there wasn't going to be a planet and like pulling on something, but I realized that it meant like if it was outside of the atmosphere instead of there wouldn't be any atmosphere at all.
True. Yeah. So planets moving around, moons moving around planets also involves gravity. And you're right, there isn't exactly air and space. But still, I mean, you could think of those as floating around each other, though, right? Gravity may or may not play a role there. So, Claudia, who do you remember agreeing with, and what was your reasoning?
I think I agreed with Ben, or I'm not sure. I just said like whoever like said that they didn't have to have atmosphere or air.
Okay.
Because like there's not really like air or atmosphere and like, so I thought that was agreed.
Like, what was your, like, have you seen footage of astronauts? Is that kind of like what you were thinking, like when they're up in space,
Yeah,
they're floating around? All right. Yeah, no, and that's good reasoning. That's the reference point that we all have, right? Is movies and actual footage of astronauts floating around. You can look up stuff on YouTube now. It's pretty fascinating. So, Alex, do you remember who you agreed with and what your reasoning was?
I think it was Kelly who said that you don't need an atmosphere for there to be gravity. Just
okay.
Because I think I learned it last year too, where like everything pulls on each other and like the moon and stuff. So
yeah, literally it's just mass and distance, and that's all you need. So, all right. Anyone else have an opinion or anything they want to share? So in terms of who is correct, the real reasoning is actually Kelly. So I can see how, and a lot of you were explaining that it is tempting to agree with Ben because our perception of astronauts in space floating around is that they're out of our atmosphere. But it really doesn't have anything to do with that, as some of you have been hinting. Gravity is literally just a force exerted by any mass on any other mass. And we'll look at a mathematical equation, as you read about too, in chapter 5. It's just the larger the mass and the closer they are together, the greater the gravitational force. So we are going to be exploring this, and my goal is to get you to understand why astronauts are floating around in space, because they are actually experiencing as much gravity as you are. It's just that they're moving really, really fast sideways. They're essentially falling around our planet constantly. So it's like a parachuter jumping out of an airplane. That's what astronauts are experiencing. They're in free fall, but they're in free fall all the time, right? They're just going around and around and around our planet rather than falling straight down to the surface. But again, that's something we'll explore in a little bit. It's kind of fascinating to think about, but a very common misconception, because we base our understanding on what we see, and we think, well, outside the atmosphere, things float around. There must not be any gravity, but there's actually no such thing as zero gravity. It always exists. We'll get to that though. Bigger thing today is, what are we going to start?
Presentations.
Solar system presentations. We'll have topic 1 and topic 2 go. Topic 1 is the sun, which is going to be Alex and Wiley. You guys feeling ready?
Yeah.
Okay, and then topic number 2 will be Paulina, Harry, and Samantha. You 3 feeling ready? All right. So here's how this is going to work. Before we actually get to the presentation, what are my expectations for the listeners? You can see everything outlined on the tasks to complete list, but essentially you need to have a notebook or piece of paper in front of you. You need to take notes. So get that ready right now. Grab your notebook, grab a piece of paper, something to write on. You need to note down the title of the presentation and the people who are presenting. Obviously, if you're giving the presentation, you don't need to do this. But everyone else who's listening, you need to do this. So first presentation is going to be The Sun by Alex and Wiley. I expect you to take at least a half a page of notes during the presentation. You're going to be taking a photo of those and submitting them to a little participation assignment that I created on Canvas. And you can see it there on the tasks to complete list as well. Topic 1, the sun notes, and topic number 2, inner planets, Mercury and Venus notes. So you're just uploading a photo there like we've been doing. If you can't figure that out, feel free to email me photos too if you need to, but it should be pretty straightforward to upload things there. And it's also good to write down any questions you have, or if there's something that kind of reminds you of something, a movie or something you might have learned about in the past. It's always fun to kind of mention those either during or after the presentation as we get through it together. And otherwise, I'll be timing. I'll give you a maximum of 15 minutes. Most groups have been averaging about 8 to 10 minutes, which is fine. Groups who are presenting too, if you want to have your video, if you have a video as part of your presentation, it's good to have that kind of loaded and ready to, or if it's in the slide, then that's pretty easy. But okay, so Wiley, who's going again? It's Wiley and Alex. How do you guys want to do this? Do you want me to open your presentation and walk through it, or does one of you want to open it and share your screen?
We can share a screen.
Okay, which one of you wants to do it? Alex, you want to do it, or Wiley?
I can do it.
You'll do it? Okay, so
Yeah.
Alex, I'm going to make you a co-pilot or a co-host, and that should allow you to share your screen. So
Okay.
if you've got any video games open, make sure you close those before we see everything.
All right. I'm sorry. I'm gonna get my notes real quick.
That's fine. Take your time. We got a little time. So, and Wiley, you feeling ready to go?
Yeah.
Okay, everyone got your notes ready? This is going to be The Sun by Wiley and Alex. It's going to be a very illuminating presentation, right? Right? No? Nothing? Not even a smile. All right, that's a tough crowd. The news, the sun has been in the news lately, if anyone's been looking. We just started a new sun cycle, which may or may not get mentioned in the presentation. We'll see. So Alex, when you're ready, you should be able to hit there's a green share screen button on the bottom. Angel, yes, you can take notes on a doc. I mean, I think, writing in a notebook is just always what I encourage because we do so much on our computers, but if you want to use a doc, that's fine. I'm not going to get in the way of that. So, and I don't know if you can, I think it's a file upload as a hand-in, so you might be able to just literally submit the Google Doc as your assignment submission. If not, just take a screenshot of what you typed and upload that. Does that sound good, Angel?
Yeah.
All right. Alex, feeling ready?
Yeah.
Want to test fire moving forward and back real quick just to make sure you're comfortable with that? It gets goofy sometimes. My class last year, yeah, it kept doing that. It kept going backwards. So if you hover your cursor down towards the lower left, you can get that control panel, and you see on the far left, you have a little forward arrow, back arrow. That might be the easiest thing to use, or use zeros.
Okay. Sorry.
Cool. All right, ready?
Yeah.
All right, let's do it.
Okay, so this is The Sun by Wiley and I. Okay, so intro to the sun. All right, the sun. The sun is 93 million miles, 150 million kilometers away from Earth, with a radius of 432,168.6 miles. The sun's surface area is 11,990 miles larger than Earth's. The sun contains 99.986% of the mass in the solar system. And the sun has a mass of 1.98 times 10 to the 30th power kilograms, or a trillion quadrillion tons. So
does everyone know what does that mean? 1.9 times 10 to the 30th. That means that's 1.9 with how many zeros on it? Anyone know?
30.
Yeah.
30.
Unimaginably large numbers. It's crazy.
Okay. Okay. So, and most of the sun is made out of, well, not most of the sun. It's all made out of plasma. So, what is plasma? Plasma is the phase of matter beyond gas consisting of positive ions and electrons rather than atoms, and this results in a more or less overall electric in a no overall electric charge. So it's neutral because the positive ions and the electrons. So it's positive negative, which is neutral.
Anyone have those things at home? What you had pictured up there? You can touch them and all the beams like go towards your finger. I don't know if anyone's seen any of those. I used to have one of those when I was a kid.
Yeah, and plasma mostly consists in either low pressure areas, like in the upper atmosphere, or in fluorescent lamps, or I think it's called a Tesla coil is what this thing is.
Yeah, Tesla coil. Mm-hmm.
Yeah, it has that, and or at very high temperatures, as in stars or in nuclear fusion reactors. And what it is, it's the fourth stage of matter. So there's gas and then there's plasma. And then solar wind. Solar wind is a stream of charged particles released from the upper atmosphere of the sun. And it comes from the corona of the sun, which I will get into later. But
pretty crazy. So everyone see how all those in that photo of Earth, it's all kind of accumulating on the north and south. Does anyone know what you can sometimes see in the sky when you're in the North Pole? It's kind of a really cool thing.
Northern Lights.
Yeah, the Northern Lights, or the Aurora Borealis, and you see it in the south too. It has to do with that. The solar wind, basically.
Yeah. So solar wind is responsible for the trails on comets, or shooting stars, or no, I think it's just comets, and it produces the Earth's northern lights and or auroras. Sunspots. Sunspots are relatively cool spots in the sun outer layers caused by magnetic fields that stop hot gases from rising to the surface. So what happens is the sun is fluid, so its equator and its poles spin at different rates. So it creates different magnetic fields, which result in sunspots. And the sun, again, like I said, is fluid, so sunspots will move around and they typically cluster. And they're typically twice the size of Earth, and they last about a week. So yeah, I thought they look pretty small, but they're actually really big, which I thought was interesting. And then layers to the sun. The solar core. So this is the core of the sun. It's 10% of the sun's total volume. The temperature inside the core is about 15 million Kelvin, or about 26,999,540 million degrees Fahrenheit, I think. And the pressure inside the solar core is about 340 billion times Earth's atmosphere. So it's really dense, and it's 12 times denser than solid lead.
Yeah, and that's
And
the secret to those fusion reactions, that high pressure. Yeah.
yeah, and it's so dense, coupled with the radiation zone, which I'll talk about later. It takes particles about 171,000 years to get from the solar core to the outside of the sun.
Hmm.
And the solar core contains helium and hydrogen atoms. And the radiation zone. So the radiation zone is just above the solar core, and it's the layers of the star, and it's the layer of a star's interior where energy is primarily transported towards the exterior by means of radiative diffusion and thermal conduction.
Which is just a fancy way of saying all the heat is moving outwards.
Yeah.
Mm-hmm.
And it takes an average of, again, like I said, 171,000 years for particles to leave the radiation zone to get to the convection zone. And over this range, the temperature of the plasma drops from about 15 million K near the core down to 1.5 million K at the base of the convection zone. So the plasma cools a lot. And then the convection zone is next, and this is, I forgot to add the picture, but convection, I didn't know what it meant, but it's pretty much just where hot plasma rises, and then so hot plasma rises from the base of the convection zone, and then it cools at the top, and then it goes back down, and it just repeats in that cycle. So it cools, gets heated again, rises, cools, gets heated again, and rises, and it keeps doing that. It's kind of, yeah.
It's very similar to what air does on the surface of Earth. Mm-hmm.
Yeah, and then I think Wiley's got the.
Yeah. Okay. So the photosphere, the luminous envelope of a star from which its light and heat radiate, means sphere of light. It's in the outer layer of the sun. The temperature is 5,800 K, which is Kelvin, and it is 500 kilometers deep. And Kelvin is related to Fahrenheit, is 0 equals negative 459.67 degrees Fahrenheit. So, yeah. And sunspots occur on the photosphere. Next one, please.
Sorry.
So the chromosphere, a reddish gaseous layer immediately above the photosphere of the sun or another star. Temperature is 10,000 Kelvin. Can be seen during eclipse and has a pinkish glow. 10,000 kilometers thick, and the chromosphere is hotter than the photosphere.
This is that if anyone's ever seen pictures of an eclipse, it looks like the moon is just, you're seeing the border of the sun, but in reality, as you said, you're seeing this layer we normally never see. Mm-hmm. It's pretty big.
The corona, the rarefield gaseous envelope of the sun and other stars, extends out several million kilometers. Temperature is 1 million Kelvin and generates powerful X-rays. And as the sun's surface, which makes the corona safe to observe during the solar eclipse. And
the name is always going to have negative connotations for everyone from now on, corona.
yeah. And its brightness, well, I already said it's not very dense, so that's why you can observe it during a solar eclipse. And this is just a image in about all the layers of the sun. And
nice.
Yeah. And the age of the sun is about 4.6 billion years old. Sun will run out of energy eventually, and when this happens, it will swell so large that it will engulf Mercury and Venus and maybe even Earth. But this is not expected to happen for another 6.5 million years before it starts snowing, because it's only halfway through a star's expected lifetime. And
I don't know if you want me to go or not.
Yeah, one more thing. It will turn into a white dwarf star after it implodes. Yeah. So solar cycles. The solar cycle, or solar magnetic activity cycle, is a nearly periodic 11-year change in the sun's activity measured in terms of variations in the number of observed sunspots on the solar surface. And right now we're in the solar cycle 25. So this began December 2019. During the cycle, the time of which the sun reaches its greatest sun activity during the 11-year cycle is believed to be in 2025. And during solar maximum, large numbers of sunspots appear and the solar irradiance output grows by about 0.07%. And the satellites, Parker Solar Probe, closest we've gotten to the sun in space and taking pictures right now. And it was launched August 12th, 2018. Goes through sun's atmosphere and will get as close as 3.8 million miles away from the surface. Earth is about 93 million miles away.
Yeah, I was about to say when it's 3.8 million miles, that doesn't sound close, but relative to everything else, that's as close as we're possibly ever going to get.
Yeah. And the main purpose is to fly into the corona to revolutionize our understanding of the sun, the corona and the solar winds to help predict and understand them, also to help forecast changes in Earth's space environment. And uses Venus gravity to slowly bring it closer to the sun. We'll get closer with every flyby and plan to take about 7 years, and it's 2 years in right now. And we have sent a total of 21 satellites to the sun. As of September 2020, the closest we have gone has been with the Parker probe at 13.5 million kilometers. And the previous record was 42.73 million kilometers with Helios 2 spacecraft in April 1972. And yeah, this is a video of the Parker satellite. And it's 3 minutes long, so if you want to cut it short or...
Yeah, do you know, have you watched it before? Is it worth watching first half, second half?
I don't know. I think it's just 5 new discoveries of the solar probe. So
All right. Let's just do like the first minute and a half.
okay.
That'd be good?
Yeah. I think I might just skip a little bit just because.
Yeah. If there's audio, I think you have to play through your speakers so that your microphone picks it up.
Oh,
which I know is a little
my bad.
weird, but and just crank up your volume.
Particles. Solar energetic particles are high-energy particles that can endanger both astronauts and satellites in space. The solar wind is the continuous outflow of particles and magnetic weather throughout our solar system. For the first time ever, we were able to go to the source of the solar wind and solar particles. Here are 5 features Parker saw. We've long known that space is full of cosmic dust. We can even see the dust from Earth because it reflects sunlight. Parker saw evidence that the dust stops at an estimated 3.5 million miles from the sun. As the dust gets closer, the sun vaporizes it, creating a dust-free zone surrounding the star. At Earth, it appears that the magnetic field lines flow evenly out from the sun, but Parker saw them behave in a surprising way. The magnetic field lines flip in a whip-like motion, turning 180 degrees around in a matter of seconds. These switchbacks came in clusters and were timed with fast-moving clumps of plasma in the solar wind. Scientists have long wondered.
Yeah, that's good. Interesting stuff about the dust and the really cool image of the magnetic waves going off the.
I'm sorry.
From there. I think you just got to go next tab over, right?
Yeah, I know, but the thing, like the menu bar is in the way.
Oh, you can try just dragging down the whole window. Click in the gray spot and just drag downwards. There you go. Yeah, I know. For all the fancy technology we have, we can't get these like silly zoom menus out of the way.
And Those are
Nice. All right. Thanks, gentlemen. Okay, can I have everyone unmute yourselves? Let's give them a little round of applause from all around the world. Well done, guys. All right. Any questions for these two sun experts or anything you're dying to know? Nice. You guys covered it so thoroughly. Everyone's minds are just blown. The one thing that I find a lot of this interesting, and we'll do some more sun stuff in our next class meeting a little bit. But for me, what always gets me is the age of the sun and how it's going to become a red giant. Does anyone know what's going to happen to Earth at that point? They mentioned it.
It's gonna turn into a dwarf star.
The sun will. What's going to happen to Earth?
There will be no Earth.
Yes, it will all get burned up. So nothing's going to last forever. So if we as a human species want to continue, we're going to have to get off this rock. But anyway, that's going to be billions and billions of years from now. So who knows? But kind of interesting fact there. So, okay. So make sure you've wrapped up your notes, and you don't have to submit the photo now. That's just a homework assignment that's due at our next class meeting. So it won't be due till Friday, but you feel free to upload them whenever you want. If no one's got any other questions or comments, we'll move on to topic number 2. We're moving out from the sun to the first 2 inner planets, Mercury and Venus, which is going to be Harry, Samantha, and Paulina, if I remember correctly. Are you 3 ready to go?
Yes.
Okay, so everyone with your notes, let's note down that we're going to learn about the inner planets with Harry, Paulina, and Samantha, right? Okay. So Harry, Paulina, and Samantha, how do you want to do this? Do you want me to share my screen? Does one of you want to do it? Harry, you're going to do it? All right. Harry, I'm going to make you a co-host, which gives you screen sharing capabilities. All right. Are the 3 of you, Samantha, and everyone also feeling ready? Yeah? Everyone got their notes ready? Okay, I'm not seeing anyone waving their hands like no, so take it away whenever you feel like it.
So today our group will talk about the inner planets, and we will especially focus on the Mercury and Venus. Our group has Paulina, Harry, and Samantha. So this is the table of contents. We have 4 parts.
Nice. Harry, can you come closer to your microphone possibly, just to have your voice come through a little clearer?
Sure.
All right.
This is the inner planet. We will talk about its definition and overall status.
So the inner planets formed about 4.5 billion years ago, and Venus and Mercury first formed when gravity pulled swirling gases and dust from together to form the first and second planet from the sun. So inner planets are the planets that are closer to the sun and those that orbit within the asteroid belt, and it's also known as the terrestrial planets because of its rocky surfaces. So the 4 inner planets have a mantle, crust, and a core in common, and we'll be focusing on the first 2 planets. And the Mercury is about 0.4 AU from the sun, and the Venus is about 0.7 AU from the sun.
So this is Mercury and Venus. We're going to talk about its major property, assumption, and transitions. So this is a full picture of Mercury. Mercury is the smallest planet in the solar system, and it is the closest to the sun. Mercury is 1.4 times larger than our moon and has a similar appearance, and it does not have any moon that goes around it. And its name doesn't relate to the liquid metal that we know. since it was named after the Roman messenger god. Uh, it has a nickname, which is the Swift planet, because it is the fastest moving planet of our system, of our solar system.
Nice.
So about the rotation and orbit period, it took Mercury 88 Earth day to complete a single orbit, which is a circle around the sun, which means that a year on Earth will equal 4 years on Mercury. And to complete a rotation around its own axis, it took about 58 days to 59 days. So let's talk about the atmosphere of Mercury. The atmosphere of Mercury is composed of a small amount of different gases like oxygen, helium, and Mercury has the thinnest layer of atmosphere because it's just have 38% of the gravity of Earth. So this is too little to hold on to what atmosphere it has, which is blown away by the solar winds.
Nice. Harry, I'm going to jump in for 1 second. So that's awesome with the oxygen and hydrogen in the atmosphere. So does anyone know if you tried to light a cigarette while standing on Mercury, what would happen with that much oxygen and hydrogen in the air? Anyone know? How do oxygen and hydrogen react to fire?
Wouldn't it cause an explosion?
Yes, you would blow yourself up. So, all right. Great, Harry. Okay, keep going.
So its thin atmosphere is made of atoms that blasted off the surface and by the solar wind and striking meteoroids. The condition of the atmosphere, it is the closest planet to the sun, so the temperature must be extremely high, when it could go up to 450 degrees Celsius. Since the heat is radiated from the sun, we hit Mercury first. But surprisingly, that there are also cold regions on this planet because it's been upright, so its pole is not really like reach to the light of the sun, so the temperature could go down to minus 179 degrees Celsius. Yeah. And
Cold.
atmosphere contain almost no air pressure or winds. So what would happen if an astronaut landed on the surface of Mercury? So it would appear similar to the moon and had the same mass as on the Mars. And the weight on Mercury is 38% of the weight on Earth. It would be hard to breathe because lack of air, and it will extremely hot, like when we melt it, due to the high temperatures.
Okay, so this Venus is the second closest planet to the sun, and it's named after the Greek goddess. Next slide, please. Its nickname is also called the Earth's sister planet because of its similarity in size with Earth, with only a 638 kilometers difference in diameter. And Venus has 81.5% of the Earth's mass, and they both have a central core, a molten mantle, and a crust. And the Venus is also called the evening stars because it is the first star-like object to appear after the sun sets. And it's really bright because Venus reflects like 70% of the light it receives from the sun.
Nice. Yeah. So a lot of people who think they're seeing like the first star come out are actually seeing a planet.
So Venus takes about 225 days to complete a single orbit and 243 days to rotate fully around its own axis.
So, sorry, I have to go back 1 second. So does everyone get that what that means is that a day on Venus is technically longer than a year? Everyone getting that? Kind of kooky to think about. Yeah, cool. All right, keep going.
So Venus has a high air pressure. It's about 90 times higher than the Earth's. And you can't witness the sunset and sunrise on Venus because of its thick atmosphere. It has a low wind rate, about 200 miles per hour, and it leads air to sit still for a long time. And it has a high CO2 rate because Venus used to have water on its surface, but because of its like closeness to its sun, the water evaporated and created the existence of CO2 and water vapor.
And it's that CO2 that you say right there, the greenhouse gases, right? Carbon dioxide is really good at capturing heat, so that's what's giving you those extremely high temperatures you have mentioned there.
Yeah.
So Venus is known as the hottest planet in the solar system. This is because Venus has the thickest atmosphere, which contains 96% of CO2 and water vapor, known as the greenhouse gases, and CO2 is captured it really like easy, and
Yeah.
a thick layer of opaque cloud. These two elements block the escape of infrared radiation from Earth's surface to Venus and heat from the sun. So it keeps warming up by just receiving the heat, but not releasing air, which trap the heat inside the planet and make it become the hottest planet. When the temperature could go up to 470 degrees Celsius. So when an astronaut landed on the surface of Venus, he will be crushed because of its high air pressure, and like you would feel like you are underwater. And that man wouldn't notice much of difference in gravity, and the air is so thick, so if he tried to move anything any part of his body, he would feel the resistance. So
The transition of Mercury and Venus. So the transition across the sun takes place when Mercury or Venus passes directly between the sun and a superior planet, in this case Earth, and it is similar to the solar eclipse. And both can be seen from Earth as a tiny black dot moving across the face of the sun, and it occurs about 14 times per century for Mercury and around 4 times in 243 years for Venus. And the next two slides are pictures about related to the transition.
Nice. That's cool.
So this is the location where Mercury transition happened in the past that humans like found out.
Yeah, there's some people who get like insanely excited to observe things like this. It's pretty cool.
Like Venus in this case very like special because like it only happened 4 times in 243 years, but it's like happened 2 times for in this century.
So like there's potential life forms on like Venus. So please. Okay, so scientists has found out clouds on Venus maintain phosphine, which is a kind of gas that relates on to life on Earth, and that this is like there are similarities between the dark spots found in atmosphere of Venus and bacteria as microbe life exists on Venus, and that there's a scientist that found that although there's phosphine on Venus, there's like not really big chance to have a life on Venus, but the scientist is still interested and excited about it. And please move on.
Nice. Yeah, I think it's pronounced phosphine. That's what we call it. Phosphine.
Sorry.
Yeah, no, it's hard to pronounce chemical names.
So this phosphine is a kind of toxic gas produced by animals and microbes through an unknown process, and that this is also could be formed by chemical process, and it was also used through chemical warfare through World War I, and it was found like in the bottom of the lakes of like sludges and like in penguin waste of pile of penguin waste and like in guts of animals, and It contains 3 hydrogen molecules and 1 phosphorus.
Yep. So think about that. Those were great examples you listed, found on like the bottoms of lakes, animal guts, and penguin poop. So how do you think this smells when we breathe it in? Do you think it smells good or doesn't smell good? Anyone want to guess?
It won't smell good.
Yeah, it doesn't smell nice.
So we're gonna watch a video like from a scientist that's explained about Sci2B on Venus.
This is great. It's super recent news.
So a group of scientists led by Jane Greaves from the University of Cardiff were looking for signs, for chemical signs on Venus that shouldn't belong there. And one of such molecules is phosphine. And they, unexpectedly, they actually were able to find a signal that belongs to this molecule. So then we raced to figure out what could be the reason for phosphine on Venus. And this is where our MIT team comes, when we actually looked at all kinds of processes, chemical and physical, that could potentially produce phosphine in Venusian environment. This is the surface of the planet is completely uninhabited. The atmosphere is the only place in which life actually could, in principle, exist. And there is a belt of clouds in there. And we concluded that there is no known chemical and physical process that could conceivably produce phosphine. So this adds to the mystery of Venus. And then this opens a very rather bold possibility that there might be something living in the clouds of Venus.
Phosphine is my favorite molecule. It looks more or less like this, a phosphorus atom on top and 3 hydrogens in the base of this pyramid. And phosphine is an extremely difficult molecule to make. It is only spontaneously made in extreme environments, such as what you find in the hellish depths of Jupiter and Saturn. It is otherwise only made either naturally by life on Earth or artificially by humans, as a fumigant, for example.
So the question is why it is actually a staggering discovery, why it is so important. Well, there are a couple of angles that you can actually answer that question with. One, the first, is that phosphine is absolutely unexpected. It cannot be produced on a rocky planet. At least we don't know of any known processes, chemical or physical, that can produce phosphine, which means either our understanding of the physics and chemistry of the rocky planet is severely incomplete, or there is some chemistry that is so unbelievably weird that it could even be life.
Nice.
So this is a preferences part where we show up photos and videos from satellites that capture Mercury and Venus.
Yeah, you're right. Mercury really does look like the moon.
Sorry. So this is like the surface, and like it glows, and like because of the air, and that it captured like a message of satellite. This one that glows.
So there's only 2 satellites that had reached Mercury.
Yeah, that's the only way we can find out a lot of this stuff is just based on the light.
It's not a long video, it's short.
And so far, it's only been visited by 2 spacecraft, NASA's Mariner 10 and Messenger. Those missions gave us much of what we know today, but future ventures are in the works with high hopes of revealing more of Mercury's secrets.
Nice.
And that NASA's satellite. This is Venus picture, and like NASA satellite captured. This one, red one, is captured by at 2012, and yellow one is like Japanese satellite. Uh, yeah, it was taken by Japanese satellite.
Nice.
The crust of Venus, however, is dotted with thousands of volcanoes, including Maxwell Montes, a volcano almost as tall as Mount Everest. Venus also has a thick, layered atmosphere. It's full of clouds that rain sulfuric acid and whip around the planet at speeds up to 224 miles per hour, faster than some Category 5 hurricanes. The atmosphere is so thick that it creates a surface pressure similar to what it would be about half a mile deep in the Earth's oceans. This pressure is heavy enough that a human standing on Venus's surface would be crushed. The atmosphere is made of greenhouse gases, primarily carbon dioxide, which create an extreme case of global warming. They trap the sun's heat, causing surface temperatures to rise over 880 degrees Fahrenheit, making Venus the hottest planet in the solar system. Venus is so inhospitable, neither humans nor spacecraft are able to survive the planet's surface. But some scientists speculate that Venus wasn't always so unwelcoming. From roughly 2.9 billion to 715 million years ago, global temperatures on Venus may have been just a few degrees cooler than Earth's are today. And scientists theorize that the surface may have contained shallow oceans that could have held enough water to support life. Today, life may still exist in Venus's atmosphere. About 30 miles up in Venus's clouds, where the temperature and surface pressure are similar to those on the surface of Earth, scientists have observed strange dark streaks that appear to be absorbing ultraviolet radiation, a phenomenon that could be evidence of microbial life. Life may struggle to survive in the atmosphere of Venus, but it is this unforgiving environment that's made Venus an icon of beauty. It reflects 70% of all the sunlight that reaches the planet, which is why Venus shines more brightly than any other planet or star in the night sky.
And that's it. Hope this video helps you guys to understand more about Venus.
Awesome. All right. Thanks very much. Can I have everyone unmute yourselves, please? Round of applause. Well done, you three. Okay, any questions or comments about Mercury and Venus and life on Venus? I found the last part of that video and the idea that Venus may have actually been a lot more like Earth, like with oceans and possible life a long time ago. That I think is pretty fascinating and makes me wonder if, as again the sun starts to expand as it ages, if Earth will eventually kind of cook and roast and turn into something like Venus and then eventually get burned up. It's kind of interesting. It's almost like we're looking back in time. So, but great, yeah, good details there. Okay, well, we don't have enough time to do. I was going to try to squeeze in one little lesson about chapter 5.1 through 5.4 in gravity. There is a video though of what I was going to do on the task to complete. So if you want to take, it's less than 5 minutes long. If you want to take a moment to watch that, you're welcome to do that. We'll just pick up where we left off with that when we meet again. So homework, I know it looks like there's a lot on the bottom of the tasks to complete list, but it's mostly just making sure you've submitted your sun notes and the Mercury and Venus notes, photos of those to those assignments. We are now more than 2 weeks into the class, so I would like to collect some feedback from you. So click on that assignment. I'm trying to keep the feedback anonymous, so you'll fill out an anonymous Google form, but then you'll type done on the assignment, and that'll be a 5-point participation grade. Check your grades. I'm trying to get things graded as I go, and otherwise just make sure that the next groups are ready to present, which is Friday. We're going to be hearing from Molly and Claudia about Earth, Mars, and then Lauren, Joyce, and Angel about the outer planets. And actually, Joyce and Angel, can I have you guys hang out here after class just for a few extra minutes?
Yeah.
Okay. Everyone got any questions on the homework? All right, thank you very much. Have a good day.